Hello class, we are working out of your Algebra 1 book 5.2 Relations and Functions. We'll be looking at x and y axis graphing, mapping, ordered pairs, tables, and actual graphs. To get started, if you are given a set of numbers labeled A, and they are in ordered pair form like this, -3, 5, 2, 2, 2, 4, and 4, -1. These are a set of numbers with a special purpose. There are no other numbers involved in the purpose of this problem to call it a set A. In ordered pairs, the -3 is an X and the 5 is a Y. So across, in ordered pairs, we are labeling an X and a Y value. We're going to present this information in several different ways. We already have one presentation right now, a set of ordered pairs labeled A. If we were to create a table for the X and Y values, we would put X on this side, Y on that side, like a T-chart. And all of the X's are the first number that we see. So we would have -3, 2, 2, and 4 for the X's. The second number are the Y's, 5, 2, 4, -1. We can write that 5, 2, 4, -1. Here's another presentation of our information or our data. We have an X and Y table. The domain are all the X's. And the range are all the Y's when you're asked for domain and range. We'll look at that more shortly. If we plot this on the plane, the X and Y axis, let's rewrite our chart over here. We're going to look at the X, the domain, as an input, and the Y, the range, as an output. So the Y is a result and dependent on the input, the independent variable X. So there's a relationship in this data, and we have an input and an output, and we always say it. We say, oh, I don't know if I can do that thing because it depends on whatever. This has to happen first. That's what we're doing here. We are creating data and plotting it on a plane based on the input and what the result of that input is for the output. So if we were to plot the point -3, 5, then on the x-axis here, we're going to go ahead and say 1, 2, 3 on the negative side. And then the y is positive, so on the y-axis here, we're going to plot the +5. And we'll say, okay, from that -3, the x, the input, 1, 2, 3, 4, 5. And we will plot our point here. Okay, so we could label that. We could say it's -3, 5. 2, 2, the next one. We have an x and y. We're going to plot a positive 2 and a positive 2. So we're going to count over 1, 2 on the x's, up 1, 2 for the positive y, and plot our point right there. 2, 2. The next one, 2, 4. We're going to say, okay, positive 2 for the x, a positive 4 for the y, from that point 2 that we already counted over from the x. 1, 2, 3, 4. You can label that point 2, 4. And our last one, 4, negative 1. We're going to count over 1, 2, 3, 4 on the x and a negative 1 on the y and label that point 4, negative 1. So we plotted all our points. From the table, and this is what they would look like. We're going to present our data in another way, and we're going to also think about whether our data is a function or not. The definition of a function is that the x coordinate is paired with only one y coordinate. So we are going to use a mapping chart to help us decide whether a set of ordered pairs is a function or not. So if you're asked to write a set of ordered pairs and you label your elements to something like a B, then keep it simple. Pick up 3 sets of ordered pairs. You could start with a 1, 2, 3 for your x's. And I'm just going to do 9, 8, 7 for my y's. And I'm going to draw a map of this element set. All the x's will go in the first part of the map. That's the domain. All the y's will go in the second part of the map. That's the range. So looking at my x's, 1, 2, 3, put them here. Looking at my y's, 9, 8, 7. I can put them in ascending order just to keep everything organized. And then I'm going to match these. 1 goes to 9 from our set. 2 goes to 8. And 3 goes to 7. The definition of a function is that only one element of the x coordinates are paired with only one element of the y coordinates. So to be a function, every element of x has to only go to one y coordinate. It has to be isolated to itself, not have several. So this element 1 in the x only goes to one element of the y, 9. This element 2 in the x only goes to one element of the y, 8. And this element of x, 3, only goes to one element of the y, 7. So is the set of ordered pairs in B a function? According to the definition, yes. Let's look at another example. If you're given set A with some ordered pairs, -3, 5, 2, 2, 2, 4, and 4, -1, then we can draw a map to help us decide whether set A is a function. Okay, so we just start plugging in our x's and our y's, the domain and range, and we're going to look at these right here. -3, 2, 4. Then we'll plug in our y's. 5, 2, 4, -1. If I put those in an ascending order, we'd have -1, 2, 4, and 5. And we can match them, see what's happening with this. So -3 goes to 5. Okay. 2 goes to 2. Okay. 2 goes to 4. Oh, that's interesting. And 4 goes to -1. Is this element set of ordered pairs a function? No, because 2 is paired with different elements of the range. 2 is paired to 2 and 4. So if we're asked if it's a function, no. Let's try another one. You have an element set B, these ordered pairs 0, 4, -1, 2, 3, 4, and -4, -3. And you map it out, x's and y's. The domain for the x's and the range for the y's. We can say 0, -1, 3, and 4. It's a -4. 0, -1, 3, and -4 for the x's. 4, 2, 4, -3 for the y's. I'll just put 4 once. Let's match them. 0 goes to 4, -1 goes to 2, 3 goes to 4, and -4 goes to -3. Alright, is this a function? The only thing that we would look at a couple of times is that in the range, 2 elements of the domain come to 4. And that's okay. That still meets the definition of a function because all of the x elements individually only go to one element of the range. So is this a function? Yes. You'll be asked to make a relation in which the domain is A and the range is the subset of B. So you'll be given sets like A equals something in a set. And these are in ordered pair form, so be aware of that. And a set of numbers not in ordered pair form, be aware of that. And if you're making a relation where the domain is A, that's all the x's, and the range is a subset of B, you're only using part of the B elements. It's a subset of B, but it has to be an element included in the whole set B. We've done this. We looked at this idea over the beginning of the year, sets and subsets. So think back. So if we do that and we draw a map and meet the purpose of our problem, we could say the domain is A. So this is the x's, the domain. And you have to use all the elements if the domain is all of A. So 2, 3, 4, 5 in order. Okay, we met that instruction. The domain is A. And looking back over our instructions, the range is a subset of B. Okay, so these are the y's, the range. We're only going to use part of the elements of B. Let's just use, we're just picking 1, 0, 1, 8, and 9, for instance. And we could say that 2 goes to 0, 3 goes to 1, 4 goes to 8, and 5 goes to 9. We're asked to make one, so it is at your choice. And in that, you can decide the relationship as well. So using all of A as the domain for the elements of the set, we chose a subset of B, and I just made it simple. There are 4 elements in A, so I chose 4 elements of the 6 in B and created a relation. You'll be asked to do that. All right, in example 4, if you look on page 190 in your book, it says, a local grocery store is having a sale on potato chips. One bag regularly sells for $2, but if you buy 2, you get a third one free. Represent the relationship between the number of bags purchased from 0 to 12 and their cost using a table and a graph. Are these ordered pairs a relation? What is the domain? What is the range? Are these ordered pairs a function? There's a lot of information here. So if you look on page 190, the input is how many bags you buy. Are you going to put 3 bags in your cart because you bought 2 and you get the third one free? Or are you going to back up a truck and load up the truck with this deal and buy all the bags from the store so you can get a whole bunch free? That's your input. It depends on how much you buy as to what the cost is. So you might be spending a little if you just put a few in your cart to get the free one, or you might be spending a lot if you're supplying an event, for instance. So the cost depends on the input, how many bags you buy. So that's why bags will be X, the input. And the result, the output, is your cost in dollars. And they call that f of x. It's a function of x. It's really your y value. It's the result of inputting whatever x amount that you decide to do. 3 bags in the cart to get the deal, or buying for a big event and backing up a truck and buying the store out of the bags of chips they have on sale. Okay, so create a scenario, think that through, put yourself in the situation. What would I buy? What would I need chips for? Do I need 3 bags at the deal, or do I need a whole bunch for something going on? Alright, you can see the first idea is taken care of in the instructions. You're using a table to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for the bag spot. And then in the table is the cost. If you buy 0 bags, you spend $0. Okay, and then so on. If you buy 1 bag, you spend $2. If you buy 2 bags, you spend $4. But with the deal, if you buy 3 bags, you get that one free. So you're still spending $4. You want a little extra deal, you buy a 4th and 5th bag, and you get the 6th bag free, but you're going to spend $8. And it's Christmas, you're going to have family in, so you buy 8 bags, but you get the 9th one free. So you're going to spend $12, and you could, in this table that you build, could buy 11 bags at $16, and you might as well get 12 bags for the same price, $16. So you have the X is the input when you're building your graph. It's how many bags you're going to buy, and the Y is the output. Well, how much will that cost you? The more you buy, the higher the cost will be. And we see that the domain are the X's, so it's set up at 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. And then we have, you're going to spend $2, $4, $6, $8, $10, $12, and so on. So when the amount of bags purchased start to plot, you would have, we're going to label this cost actually, cost. You'd have $0 spent at buying 0 bags. If you buy 1 bag, you're going to spend $2. If you buy 2 bags, you're going to spend $4. But with the deal, if you buy 3 bags, you're still going to spend $4. 4 bags is $6. 5 bags is $8. But if you buy a 6th bag, it's still going to be $8. She bought 2 bags and get 1 free. 7 bags, you're at $10. 8 bags, you're at $12, and at 9 bags, you still only spend $12 because you get the buy 2, get 1 free deal. So every time you have an input, you have 1 output. So yes, this is a function. No element of the domain, the X's, relate to more than 1 element of the range. So you see the table built for X's and a function of X, the Y's. You see a graph built from that table. You determine if it's a relation. What is the domain? The domain are all the possible values of X. And the range is all the possible values of Y. And since only 1 element of the domain relates to 1 element of the range, it is a function. We've answered all the questions. I hope this helps, and I'll see you soon.